rapamycin, is still the gold standard in terms of a pharmacological intervention for slowing aging in laboratory animals. It robustly increases lifespan and multiple health span metrics in every organism where it's ever been tested in the laboratory. The largest effect on lifespan in a mouse is an experiment that was done 40 plus years ago by Rick Weindrich and Roy Walford, right? Culturally, within the field, there was this formalization of these things called the hallmarks of aging. The hallmarks of aging have been great, but one of the consequences is it narrowed the research that was happening in the field to 99.9% of the studies in the field are within that framework of the hallmarks of aging. Some of the things we've learned is that, in general, at the doses that people are using rapamycin off-label, it is extremely safe. The only side effect that is statistically significant is
Matt Kaeberlein, one of, if not the most prominent longevity scientist in the world, I was thinking unusually long and hard about what should be my very first question to you.
Mhm.
At last, I have settled on an exceptionally deep one. However, I can't take full credit for it. So some days ago, I created a new thread on the rapamycin.news forum section. You might be familiar with that. I asked,
Sure.
what would you ask from Matt Kaeberlein? And many questions came in. You might even do an Ask Me Anything session there if you can keep up. And there was some real deep one, like even I was hardly able to decipher them. But there was one that stand out. It is from the user called Amuser. What's his favorite color?
What's my favorite color? Oh, wow. Uh, I I would say I gravitate towards dark blue, although, honestly, it really depends on the day. I can't say that I have a favorite color that it would be the same from day to day. So my truck, which I love, by the way, I have a Rivian truck, is forest green, and I've come to absolutely love that color. So depends on the day.
Well, what's the point if you can't have fun? But this is also a point I would like to make here, because many people who are not into longevity, geroscience, or any of these crazy things are not really looking for longevity escape velocity, but
Sure.
more like they are looking for hedonism escape velocity. I guess you can figure out what that means. And my question to you is that even in the realm of possibilities for us to ever achieve that?
So you're thinking like the easy path to health? Is that kind of where you're going? Like, wouldn't it be great if we could achieve maybe not, longevity escape velocity, but maximum healthy lifespan without having to put in any work? Is that the question?
You see, it goes even further than that. So when I was thinking about it, I could imagine two things here. One is that you might be a young person. Young people can get away with some really
Sure.
crazy shit that we cannot
Yeah,
anymore.
I know. Believe me, I did. And if we could live like that for our entire lives without having to face consequences, yeah, I don't know. I mean, to be honest with you, I haven't ever really spent a lot of time thinking about it through that sort of a lens. I guess, given where I'm at in my life now, certainly if I look back at some of the stuff I did, when I was younger, I was young and stupid like everybody, and did a lot of things, including things to my body that, I may be paying the price for a little bit now, but I was fortunate
What?
well, I mean, I certainly did my fair share of alcohol and drugs and risky behaviors, some of which, I came close to not making it this far a couple of times, stuff that guys, I mean, not only guys, but I think guys who are teenagers or young adults are more prone to do, like, driving in ways that are maybe irresponsible. So all of that's just to say that looking back now, I don't know. I can't say that I miss doing those kinds of things now. And I can't say that I would want to be able to necessarily, do drugs and alcohol and eat whatever I want. And that's something I desire. I can't say that I desire to be able to do that with no consequences. I mean, first of all, the reality is that's not life. I don't think we're ever going to get to a point where there's a magic pill that allows you to engage in hedonistic activities without any consequences. It's possible, I suppose, but I don't see it happening. And so I personally don't see the value in spending a lot of time wishing for that. And I'm not sure I would wish for it anyways. I don't honestly know how many people really wish for that. I'm sure some do, but I certainly don't see that as a motivating force for those of us who are trying to make progress in the space, right? Like the goal is not to find a pill that allows people to eat whatever they want and be sedentary and drink as much alcohol as they want and escape the consequences. First of all, I don't think that's going to happen. And second, I don't necessarily think that's a good thing. And it's not a great answer to your question, but honestly, I haven't spent a lot of time thinking about it, and I'm not sure it's a productive line of thought for me to go down because I think there are more important things I'd rather spend my time focusing on.
All righty. Then let's handle the easy questions then, how to achieve longevity, escape velocity.
Sure, more money would be number one.
Money, I know money. I know money. That's Bitcoin. The answer is Bitcoin there, but but I might be a bit religious about that. Okay, look, I have a dilemma, a big dilemma, and I asked this from many people in the show, so many that probably this will be the last time that I ask this from anyone. I'm going to retire this question after this.
Okay, pressure's on.
The mouse in the laboratory dilemma. In the last 5 years, I decided to check in longevity, what's going on in longevity. And my experiment was that every year I send in the exact same question to the longevity subreddit. How long can scientists make a mouse live in a laboratory? And unfortunately, the answer did not change. So yeah, my question is that if we can't even make progress on mouse lifespan in absolute terms, do we have any hope here?
Yeah, I think that's a good question. I wish more people were asking it. And I agree with you. This is something that I have been frustrated by and have pointed out repeatedly to my colleagues in the scientific community who don't like me continuing to point out that the largest effect on lifespan in a mouse is an experiment that was done 40 plus years ago by Rick Weindrich and Roy Walford, right? Yeah. So I think if you look at it through that lens, it's hard to have a lot of optimism that we are approaching longevity escape velocity because the data just aren't there to support the idea that we can get larger and larger impacts on lifespan, even where it should be relatively simple in a laboratory animal like a mouse in very controlled conditions. We just haven't been able to do that. Now, I would also be careful, though, to interpret that in a balanced way. So I don't view that as evidence that we can't have extreme lifespan extension or that we can't get there. I think it's important to look at why we haven't improved that mouse lifespan impact. I believe there are a couple of factors. One, I sort of alluded to just a second ago when I talked about money. So if you look at the amount of resources that have gone into studying the biology of aging, it's about 1/2 of 1% of the biomedical research budget in the United States. And if you compare that to how much money we've put into cancer, for example, we put about 20 times the resources into studying cancer as we have into studying the biology of aging, despite the fact that aging is the greatest risk factor for 9 of the top 10 causes of death in the United States, including most forms of cancer. So there's been a huge resource misallocation. So that's one reason why we haven't been able to move the needle in terms of lifespan, at least in laboratory animals. I think the other reason is culturally within the field. Starting in about 2009, there was this formalization of these things called the hallmarks of aging. The hallmarks of aging have been great. They have helped us create categories of types of damage that occur during aging. Think about it in a much more sort of mechanistic framework. But one of the consequences is that it narrowed the research that was happening in the field to 99.9% of the studies in the field are within that framework of the hallmarks of aging. So there are very few people looking at what we don't know yet, and a lot of people studying more or less what we do know. And that has, I believe, led to us becoming very deep in terms of understanding these hallmarks of aging, but very narrow in terms of being able to identify new mechanisms, new pathways, new targets where we might get much larger effects on lifespan. And so I have advocated for several years now that we need to expand that. We need to go back, at least to some extent, to what I call unbiased discovery science. Quit pretending like we know enough for the biology to figure it out, and let the biology tell us what's most important. And I'll just dovetail a little bit because people are very excited about AI with good reason today. The new AI tools are phenomenal, and they're only as good as the data we put into them. And so there are lots of people who believe that AI is going to solve aging. And my point is, we've got to give the AI tools enough data to be able to actually extrapolate and integrate. And if we do it with the data set we have now, we're not going to, I don't believe we are not going to have large impacts on lifespan simply by employing the AI tools that are coming online. I think we need to pair that with more large data sets, more discovery science, looking outside the hallmarks of aging. So I view it as discouraging a little bit, disappointing, but I certainly would not view the fact that we haven't been able to have large effects on lifespan in laboratory animals as an indication that it's not possible, or even that's gonna be all that hard. I think we just need to we need to reallocate resources, and we need to change our approach so that we enable large scale discovery science in the field.
Well, how do we do that?
Well, I think that there is some reason to be optimistic on the resource allocation side. So we have seen a small number, but I think significant allocation of resources in the private sector, things like Altos Labs, Calico. I think we'll see more of those. There have been several smaller companies that aren't in the level of billions of dollars, but hundreds of millions of dollars coming online. So that's promising. I think we will see big pharma jump in soon. We're already starting to hear hints of that. So that's a resource allocation. And then I'm hopeful that with a growing awareness, there seems to be a buzz in the air, certainly around longevity as a buzzword. I'm hoping that that will translate to a growing awareness of the science of longevity, and not just the pseudoscience and the noise, but the real science. And that there will be, among policymakers, legislators, reallocation of resources within the current, federal funding environment. Not It'd be great to have more money go to basic research, but even within the current federal funding environment, a reallocation of resources towards more fundamental, proactive, preventative approaches. And my belief is that targeting the biological mechanisms of aging is the best way to keep people healthy. And so if we are really interested in this make America healthy again, I'm not sure America was really ever healthy, but make America healthy, the best way to do that from a basic research perspective is to understand what are the fundamental mechanisms of aging and do something about it. In that way, we will slow all of the diseases of aging and improve function across every tissue and organ in the body simultaneously. What we have done up until this point largely is siloed diseases. We wait until people get sick and then we keep them alive. And I'm all for keeping people alive, but wouldn't it be better to keep healthy people alive than keep sick people alive?
I am actually working on this exact same problem myself, and I'm going at it from a very unique point of view. And I'm wondering what's your take on my vision here. As you mentioned, perhaps the bottleneck of longevity science is money or resources, but ultimately, what do they buy? They buy people's energy, right?
Mhm.
People people's expertise energy of trying to work towards that same goal. And there is a technology out there that is aimed to hijacking people's motivation and give them goals and constraints. And then the people are going to work as hard as they have never worked for anything else before to achieve that goal. This technology is called the game. Games are doing that. If you think about
Sure.
it, a game
Gamification.
is
Sure. Yeah.
a set of rules and a goal. I wanted to talk to you about the biological aging clocks before I tell you about this, but
Sure.
we can talk about it later. Now, if the goal is to try to reverse our age, then these very imperfect biological aging clocks are the measurement of that goal. And eventually they are going to get better. If we are competing against with each other on trying to reverse our biological age, then we could achieve some really big things. Let me just give you two examples of intuition of why this is so big. So, first of all, there was a bodybuilding coach, don't remember who said to his client that, hey, look, if you want me to give you scientific citations about everything that I'm giving to you, then you're never going to be Mr. Olympia. Bro science got a lot of things wrong, but bodybuilders figured out how to get big muscles before science really got into the field. So that's one intuition here, that perhaps we can do the same in longevity. Or the other one is, again, the game aspect of it is that I punch you in the face. That would be not nice. That would be unethical and illegal. But what if I do it in the frames of a boxing match, a game, right? Suddenly, it's not only legal and ethical, but other people are going to cheer for us to punch each other in the game.
Sure.
It's complete madness. It's complete madness, you know? So this is how games hijack the motivations of the people.
So a few thoughts. I mean, I think this is definitely worth exploring, and we're starting to see initial forays into gamification of health, right? I mean, that's really what we're talking about. So one thought is, when you say biological aging clocks, what you really mean are health metrics. That's what we're really looking at, right? We're not actually measuring biological age. And we can come back and do a deep dive in that, but that's just a fact. So the people who say they're measuring biological age are either misinformed or they're lying. They're not measuring biological age. What they are giving you is a proxy for some overall metric of health. And so can we gamify health? Yes, I think we can. And I think there's value there, but that's not going to achieve the goal that we started with, which is, can we get to longevity escape velocity? And again, we can come back why I say that. I think you have to really think about what is your goal. And I think there's value to gamifying health, but it's not going to get us to the next level of understanding aging to the point where I don't believe where we can get large effects on lifespan. The other thing I do want to push back a little bit on is this bodybuilding analogy, because you said that they got there without science. That's absolutely false. They all used science. What they did was they got there outside of the sort of traditional regulatory framework and what mainstream science would view as ethical experimentation. They got there by experimenting on other people and on themselves, but it was all based on science. All of the, anabolic steroids are based on science around anabolic hormones, right? So science was fundamental to that, and I think it's going to be fundamental. But it is an interesting parallel to look at what is happening, in offshore clinics, in hotel rooms in Vegas, right? With some of these experimental therapies and the parallels with, what was happening in the bodybuilding world 30, 40 years ago, 50 years ago. It's interesting to think about. The one thing I would say is, in bodybuilding, again, the goal is different, right? The goal there is to meet some, set of more or less arbitrary but agreed upon standards of what it means to have the perfect physique without any real care for what that does to your long-term health, right? Health span or lifespan. And so experimental science that achieves that goal in that context in the short term, because that's a short-term goal, right? It's how am I going to look 3 months from now when I'm up on stage? Experimental science to achieve a short-term goal can be effective because you don't really care about the long-term consequences. If the goal is to maximize health span and or lifespan, you do care about the long-term consequences. And so when you think about this from a risk reward analysis, the risk part of that's something you may be doing with your experimental gene therapy or your pig exosomes or whatever you're putting in your body may have long-term consequences that you can't anticipate. You need to be aware of that when you do that sort of risk reward analysis. So it's an intriguing parallel, but it's also very different. And so I hesitate to put too much credence in the idea that, well, the bodybuilders did it and it worked, so the longevity enthusiasts should do it, because it's a different scenario in this case, I think.
Possible, but you know, again, what's the point if you can't have fun? Because this is a game.
I'm all for having fun, believe me. I mean, actually, I wanna double click on that because I do think, a lot of people in the longevity bubble lose sight of the fact that if you don't have any joy in your life, like, what's the point? So, I'm totally with you that having fun, finding joy is, maybe the most important part of this, and you can live a long time, but if you live a long time and you're miserable, what's the point?
That's a pretty good point that they were using science. It's just something happened to science today that it became a bit more elitist, or I don't know how you would call it. It seems to me that you kind of got away from academia from the past few, I don't know, years. Is
Yeah,
that correct observation? And if so, why?
right. Yeah, so in my situation, I spent 20 plus years as a hardcore academic at the University of Washington running a pretty large research lab. And, there were a lot of good things about a career as an academic scientist, a lot of good memories, but I also, especially towards the end, felt like so much of my time was spent doing bureaucratic busy work. And I am somebody who is motivated by feeling like I'm making an impact, that I'm doing something important, and that I'm doing something that I love. And I don't love doing paperwork. I don't love sitting in committee meetings. And I don't feel that those are important uses of my time. And so I felt like I was spending a lot of my time doing unimportant things. And so that was one major reason that I felt like I needed to look outside of academia. The other, much, I think, more specific tipping point for me was a recognition that it's really hard to do anything that is what I would consider a big idea in academic science in a timely way. And I'll give a perfect example, at least for me, that crystallized it. So, it was back in 2014 when I had the realization that we know enough now to slow aging in people's dogs and make their dogs live longer, healthier lives. And as soon as I had that realization, I was like, this has to happen and I have to do it. And it took 10 years to get that project actually funded at any reasonable level. And that still, when I just say that, it pisses me off how long it took, because it should be obvious. Like, that's a no brainer. If we can give people's companion animals 20 to 30% more healthy life, and it's pretty easy and it won't cost that much money, we should do it. Like, it should not be something that takes 10 years to actually get off the ground. And so, you know, I had that realization that I don't know how many more 10-year cycles I have, hopefully several if we're successful, but I don't want to have to fight the academic bureaucracy the next time I have an idea that needs to happen. And I realized the only way I was ever going to be in a position where I could enable those kinds of ideas, myself or other people's ideas that I feel passionate about, was not going to happen in academia. And so I needed to look outside of academia. So it was really those two things that led me to be open to other possibilities. And again, there are lots of good parts of academia. I'm not somebody who bashes it, but for me personally, it was just time for me to look elsewhere.
You see, I want to come back a bit more about the philosophy of science here, but it might be the perfect time to bring in the most upvoted question from the Rapamycin news
Okay.
from Rapamycin.
Oh, Brian.
You know him? So when can we expect results? Preliminary is fine from the triad study.
Yeah, great. And this ties right into what I was just saying, right? So the answer is we're probably 4 years out before the trial's completely done. And the reason for that is, again, in part because of the absurd way that we fund research in academia, right? I mean, there was obviously a global pandemic that slowed things down, but what really slowed the rapamycin trial down was when the NIA, the National Institute on Aging, failed to refund the grant that was supporting that trial. It was halfway done, and they stopped funding it. And it is now refunded a year and a half, 2 years later. But that gap in funding basically meant the whole thing had to shut down. And again, there's a lot that goes into setting up a multi-site clinical trial of 580 dogs. So the answer is we're probably 4 years out. Would I like it if the trial was done? Yeah. Does it upset me that we still have 4 years to go? Yeah. And I can tell you why it's gonna be 4 years. Maybe that's worth just double clicking on. And this is part of my frustration with academia that led me to leave academia is the just absurd way that decisions are made and resources are allocated. And I know that's not look, I'm not I know that happens in the private sector too. I'm not somebody who says life is gonna be completely different, but there are just so many challenges with doing anything important in academia because the bureaucrats run the show. Anyways, so the reason why we're probably 4 years out is we probably have another year of recruitment. The trial has been going and going well, and dogs are actually completing the full clinical trial. But in order to get up to 580, we probably have a year of recruitment left. And then once the last dog is randomized into the trial, it's a 1-year treatment period and 2-year follow-up. So when the last dog has completed the treatment period, we will be able to do an interim analysis, and we may be able to publish some results then. I'm just not sure. But lifespan is the primary endpoint. And so our statistics on lifespan tell us we will likely need all of the dogs to complete that full 3 years follow-up before there's sufficient mortality in either the placebo or the treatment group to be able to say anything about lifespan. So that's where I get the 4-year number from. Could it be a little longer? Could it be a little shorter? Sure. But assuming we finish enrollment in the next year, the next 12 months, then it's a 3-year window before that last dog completes the trial.
I see. All right. All right. Well, then, look, I also have a more not greedy, selfish question about being a scientist. I spent 10 years on being a developer and the last, let's say, 5 years as a privacy researcher. And I owned the cryptographic privacy literature of Bitcoin. And, we are talking about less than 100 scientific paper. I only wrote 2, but it was really hard to even keep up with what's going on in that very narrow little field. So how the hell are you guys able to even keep up with anything in nutrition and medicine?
That's a great question. So, a couple things I would say just from my own personal experience. It was much easier for me personally to keep up with the field of aging biology 15 years ago because it was fairly small. It wasn't as small as 100 papers in total, but it was fairly small. And if you go to lots of conferences, it's mostly the same people, the same labs that are producing most of the high impact work. And so I personally found it not very difficult to keep up with the literature. And I'll say one of my prior and ongoing frustrations is with people in the field who style themselves or are talked about as if they are experts. Again, mostly very successful academic scientists who do good science, who only know their own narrow little area of research and yet will talk with confidence about things that are outside of that narrow little area of research. And most of those people, in my view, are not very critical thinkers. In other words, they'll hear somebody else at a conference say something about that person's research and they'll just believe it. And I mean, the reality is, as scientists, we're supposed to always be probing and asking questions and thinking carefully and coming up with alternative hypotheses. I feel like, unfortunately, in science today, a lot of people are not trained to do that. And so they just accept what somebody else says if it's not right in their own little wheelhouse. So they'll be critical about science in their own little wheelhouse, but they get outside of that and they'll just accept what people say. So the question you're asking is actually quite problematic in the field of aging biology or longevity today, because there aren't very many people who have even moderate expertise across all of the domains of aging biology. And that causes them to not be critical in the way they think about work that's outside of their own narrow little area and just accept what is written in review articles or what they hear somebody say at a meeting. And that's how bad ideas, mistakes get sort of cemented into the scientific literature. So it's a challenge today because the field has expanded. It's a good problem to have. The field has expanded. There's a lot more research happening, and it becomes even more important, not necessarily that people be experts on everything, but that people recognize the limitations of their expertise and where their knowledge ends, and not make statements as if they are experts in a topic unless they've actually done the research. The one thing that I think is quite powerful, so I touched on, AI tools that are becoming more and more powerful. I think the AI tools that are available now for aggregating scientific research, and if you know the right way to probe them, can accelerate the process of maintaining working knowledge of a broad field, right? Like aging biology. Again, one of the things that might be worth just stating explicitly, one of the things that makes aging biology challenging as a field to maintain expertise in is how broad it is. If you think about all of the things that happen during aging, right? It incorporates most of the major chronic diseases that people experience. Every tissue and organ in the body ages. We're talking about literature that spans, 6 common model organisms and another 5 or 6 that are less common, but still used regularly in the field. So it's a huge, diverse body of literature to try to stay up on. And so I would say, what I would hope for in my colleagues and what I try to do in my own life is maintain a broad understanding, pay attention to the big results, understand where my expertise begins and ends, so give appropriate disclaimers when I'm speculating, and utilize the tools that are available to do the best you can to keep up.
Okay, many questions there, but I guess I'm only going to ask one. The other side of this problem is that people who are not experts in these topics, like me, of course, I have some feel about it because I'm podcasting about it, but ultimately,
Sure.
I'm just a monkey.
We all are.
So, the other side of the story, how should people learn the truth about any topics who don't have the expertise?
Yeah, I mean, there is no easy answer to that
Is
question.
there
Again,
any
I think
answer?
I think it starts with understanding the limitations of your knowledge, right? So I guess I would maybe break this down into a couple of categories, right? One is, how do consumers recognize good information from bad information, experts from non-experts? The other is, if you're somebody who wants to become an expert, how do you get that expertise? And those are related, but different audiences. So I think if you're talking about consumers, right, people who want information, there are a couple of rules of thumb, I think, that are really useful to recognize the people who are honest, have expertise, and are trying to give good information from those who aren't. One obviously is credentials. Like, is the person actually an expert in longevity? There are lots of people who call themselves longevity experts now who have no background in longevity. Doesn't mean they can't have learned the information, but by and large, if somebody has no track record in the field, whether it's longevity or anywhere else, you should be skeptical of whether they are actually an expert, despite what they call themselves. So that would be one thing I would point to. Another would be, do they speak in certainties? Like, I think people who tend to talk about one size fits all answers and 100% certainty about a certain topic often don't have sufficient knowledge to recognize where their knowledge ends, right? I think people who actually understand the complexity of the biology of aging, as an example, are very hesitant to talk with 100% certainty about a lot of things in that realm because they recognize how much we don't know. This goes back to what I was alluding to earlier, how much unknown there is. So instead, we tend to talk in terms of probabilities. The challenge lies in the fact that most people don't want probabilities. They don't want uncertainty. They want easy answers. And so the people who get a lot of clicks are the ones, who talk about reversing aging or cures for Alzheimer's disease or, whatever, because it's a very appealing, simple clickbait answer, but it's not reality. I guess the take home would be don't gravitate towards clickbait, actually be curious about understanding the complexities of the situation if you want real truth. And then I think be wary of people who are trying to sell you something. Like that should be pretty obvious, but there's a lot of people in this space who are trying to get rich. They're trying to sell you something and they will tell you anything that they think you want to hear in order to get you to buy their product. So, be careful of people who are trying to sell you something. And then for people who want to become experts, I would say, again, recognize where your knowledge ends, be curious, and get your information from as credible of sources as you can when you're trying to build up expertise. And so what are the credible sources? I mean, obviously the scientific literature is a good place to start, right? That's going to be, even given all the problems in the scientific literature, that's largely going to be the gold standard that you would go to if you want actual real data. And again, I think using the tools that are available in terms of AI-based tools, like the current iteration of ChatGPT, understanding the limitations to that tool, but utilizing it to gather information and always take a skeptical approach, right? Always ask, if somebody's telling me something, what's the alternative explanation? Is there an alternative explanation? What might that be? Is there an obvious alternative explanation? I think this is where I struggle a little bit because, I've been trained as a scientist. I understand how to think critically and how to seek alternative explanations when somebody tries to present me with a model. I also understand that our models are always wrong. Like, I think fundamentally, that's really an important concept for people to get. Our models are always wrong. Models are, by definition, an imperfect representation of reality. They are wrong. The key is to figure out how they're wrong. Maybe they're wrong in small ways, maybe they're wrong in large ways. But start from that framework. How is this explanation incomplete? What might be an alternative explanation is a really, really useful way to think about information that people are presenting you with. Now, you have to balance it. You can't be the guy who disbelieves everything. But I think starting from that framework is really useful. And where I struggle with this is I see so many people believe things that are so obviously untrue, like obviously untrue, just because they want to believe it.
What is truth?
Uh, I think there are, well, that's a good question. I think understanding what are facts and what's information where there's a probabilistic component to it, right? Now, again, you can take this to degrees that I think are outside of a scientific discussion. You get philosophical about what's reality. And again, to me, those are fun conversations to have among friends. I don't think that's a useful way to live your life by just questioning whether you can believe anything because we don't know what reality is. I think there are facts that we can believe. There are things that are real. If I look outside and I see there are no clouds in the sky and I see the sun, it is a fact that it is a sunny day where I'm at, right? So I think there are facts that we can count on. There are data that we can believe were generated and the data themselves are real, but we can question whether they are accurate, right? So this is where I think you're starting to parse the difference between, what is a fact and then what is the accuracy around specific information points that people use to justify their beliefs about something, of their models, right? And so that's where I would put truth as things that are real, that we can demonstrate, that we can document. And I would put data that we can have a high degree of confidence in as close to truth, right? It's maybe the case that there is a possibility that something is not accurate, but it's a tiny possibility. And so we can almost think of it the same way as being truth. At least that's the way I sort of approach, my evaluation of information.
You see there, yeah, we can go philosophical in it and then go on the route of the skeptic of there is an evil demon that's trying to convince us that if we go outside and look, the sun is shining. That's not
Well,
actually true.
again, though, that
But
that I put in the realm of faith, right? So belief in the absence of evidence is faith, and I'm not interested in faith at this point, right? I mean, I think there's a place if you wanna have faith in things, there's a place for that, but it's not science. Again, I'm a pretty
I want
pragmatic guy. I just don't find that
that's
useful.
that's what I wanted to say.
Yeah.
Pragmatism. I believe
Yeah.
that's what differentiates between what's useful and what isn't, because the pragmatic truth is what works, you know, whatever what works, that's the
Yeah.
pragmatic truth. And that's something how people can live their life through. All right. Okay, let's go with this. Science, the history of science is about doing more with less.
Is that a question?
I saw that your brain started working there, so
I guess what I'm wondering, I'm not sure that that's the way I would frame the history of science. I would say that's one outcome of scientific progress and technology is being able to accomplish more with fewer resources allocated towards, whatever it is that you're trying to accomplish. I think science, the way I think about science is more about an approach to understanding reality that is based on developing models and then identifying ways to disprove those models or those hypotheses. That's the way I think about science. It's much more an approach to understanding the world around us or the universe. And one outcome of success in science is being able to accomplish more technology that allows us to accomplish more with fewer resources. But that's not fundamental to the approach itself. Does that make sense?
I'm not sure. I mean, understanding is a tool. So I believe understanding is a tool to achieve some outcomes in the real world instead of the end in itself.
Well, it is, but there are a variety of approaches that can be taken towards increasing our understanding of the universe. And the scientific method is a specific approach that's based on logic and trying to disprove hypotheses, right? This is again goes back to the difference between philosophy, right, and other approaches that were used before science was developed to explain observations versus a very specific approach to explaining observations, which is about developing models, hypotheses, and then working to disprove those hypotheses. That's, I think, maybe a fundamental misunderstanding people have about science, right? Especially a lot of scientists. You hear a lot of scientists talk about, we set out to prove our hypothesis in their papers, right? And I'm like, that's exactly the opposite of the approach you should be taking, right? Because when you set out to prove something that you think is true, you make mistakes. If your goal is to figure out how your model is deficient, that, I believe, is kind of the core principle around the scientific method. So again, the applied outcome of science indeed should be technological progress, right? Accomplishing things that improve outcomes for people and the world around us. But the scientific method itself is independent of that. It does not require that outcome.
If you test long and hard enough, you can get whatever results you want.
No, I don't actually believe that's true. I think if what you're saying is one of the problems that we run into sometimes in the scientific literature are people who cherry pick their result and only present the result that they want you to believe, even though all the other times they did the experiment, they got a different result. That does happen. It's not as widespread as I think some people would like to believe, but it does happen, and that's scientific misconduct. But that's not something we have statistical tools to guard against that, and rigorous scientists use those tools.
You know, I I think I'm going to concede on this and be pragmatic because I wanted to go to a completely different place from here. I wanted to make a point about the importance of supplements versus lifestyle and
Sure.
kind of pick a fight with you on this. That the thing that's improving is technology, and technology of lifestyle is not improving as fast as the technology of supplements, because the supplements have very small costs. Taking a pill, let's say a day, that's a very small cost compared to garner all your motivation and do a 1 hour workout, let's say. Also a small cost to research a supplement compared to research how you train. I don't even have a question here. I just want to hear your thoughts on this.
Sure. Yeah. So, I mean, I think again, from the kind of purely conceptual or hypothetical, I agree with you that if we had a supplement or a pill that allowed people to get all of the benefits of the perfect lifestyle and then some more, that would be a much more likely to be widely adopted approach than people exercising and eating a healthy diet and focusing on their sleep and their relationships, right? Which is what I would put under the lifestyle bucket. So conceptually, sure. Reality, though, we don't have that. I don't think we're ever going to get it. And I think your question, your one of the points you tried to make, which is that, well, we should be able to research that in supplements and figure it out, and it should cost less to do that than it would to research nutrition and exercise. Maybe. The reality, though, is the incentive structure in the supplement industry right now actually ensures we never actually do that research. You don't see supplement companies proving that their supplements work. You see them making dishonest claims and selling supplements because they're allowed to do that. And in fact, they are disincentivized from proving whether or not their supplements work. So I would love to see an incentive structure that actually led to real high quality data on which supplements provide value, which don't, which might actually be counterproductive. What do combinations of supplements do? Because we don't know anything about the combinatorial interactions. I would love to see that research, but it's not happening. And I don't see it happening because the incentive structures are all pointing towards making money by deceptive marketing and not actually figuring out what works. So again, from a pragmatic perspective, I just don't see it happening. Now, maybe that will change in the future, but at least right now, that's, I believe, is the situation that we're in, which is one of the reasons why I'm not against supplements at all. I just feel like there are a very small number of supplements that are likely to provide long-term benefit. And for some of those, you need to measure whether or not you're deficient or suboptimal in order for it to make sense to know what to supplement. And for those people who want to take 20, 30, 40, 120 pills a day, there are risks associated with doing that, both because of the combinatorial interactions of these molecules and the other stuff as part of the manufacturing process that gets put into these supplements that, in small quantities might not be a big deal, but if you're taking a lot of supplements, can accumulate in your bodies and might cause unanticipated detrimental consequences that offset any potential benefits that you might get. And I think most people don't think about that. And the supplement industry, of course, is going to try to make you believe that that's not something you should think about because they want your money.
Let's talk about the supplement that you are an expert in. Rapamycin .news. So I'm a person who's running the Longevity World Cup, and someone posted about the Longevity World Cup on to the Rapamycin.news forum, and I was astonished by what the hell is going on here. A supplement has a forum that is like talking about the entire longevity field. Like, not every supplement has their own forums. What's the deal with Rapamycin?
Yeah. So a couple of things to say. Just one point of clarification, rapamycin, at least in sort of the general, the way most people would define a supplement, it's not a nutritional supplement. So it's a regulated pharmaceutical. It is a prescription medication. It's not available over the counter, like something like creatine would be, right? So it's just useful to differentiate. And when I was talking about the incentive structures around supplements, I was talking about over-the-counter supplements that are not regulated the same way, or really at all in most cases. A pharmaceutical medication, a prescription medication, is going to be regulated differently. There are problems with the incentive structures there, but it's a different set of problems than the incentive structures in the nutraceutical or over-the-counter supplement space. So rapamycin is prescription medication. You legally are required to get a doctor's prescription, at least in the United States, to get rapamycin. So I think the interesting question that you raised is, why is there this entire forum around rapamycin that is not even specific to rapamycin? Like, those members of the rapamycin.news forum talk about all sorts of longevity science. I mean, I think part of it's kind of a unique evolution of the data around rapamycin and the people who have gravitated towards off-label use of rapamycin for the purposes of potentially improving their health span and or lifespan. It was started by a guy named Brian, who is very, he's a tech guy, but he's very scientifically literate. It was a passion project for him, and a core group of initial users gravitated around this topic. But they all were people who are, in my view at least, for non-scientists by and large, extremely well informed, very curious, really want to know the answer. Like, there are a lot of people on the rapamycin.news forum who maintain, like I try to, a healthy skepticism about rapamycin. We don't really know for sure that rapamycin is going to improve health span or lifespan, broadly speaking, across the population, or in which individuals it will have that effect. So I think it's an interesting group of people who gravitated to rapamycin, as opposed to some of the other stuff that's out there, like NAD boosters or metformin, which sort of got popularized among a different audience of people who are less scientifically informed and skeptical. Also a larger audience, right? A larger audience. So this was a core group of much smaller group of people who I think have a true interest in understanding the biology of aging, many of them. And that's why you see a much more sophisticated, in general, conversation on the rapamycin.news forum than you will on a NAD booster webpage, right? Or Facebook. So that's at least my sort of perspective on why that forum has evolved the way that it has. And that's not to say that there aren't trolls on there and there isn't misinformation. But by and large, I think Brian and the other core members of that forum do a pretty good job of appropriately responding to misinformation when it gets posted.
Okay, so it's a historical perspective, but then again, the question still stands. What's the deal with rapamycin?
Sure. Yeah. I mean, I think, and I mean, it's a little bit frustrating to me that the answer to that question hasn't changed a lot in the last 3 to 4 years. If you'd asked me 3 to 4 years ago, what's the deal with rapamycin, I would say pretty much the same thing, which is that it is still the gold standard in terms of a pharmacological, so a non-caloric restriction, basically intervention for slowing aging in laboratory animals. It robustly increases lifespan and multiple health span metrics in every organism where it's ever been tested in the laboratory. And it's been reproduced dozens of times now. Everybody knows it works. Everybody in the field believes it works. And it's our best candidate. Am I frustrated by the fact that we don't have a better candidate in the last 5 or 10 years? Yeah, we should, but we don't. So then the question really, I think the more interesting question is, and we can talk a lot about what we know from the preclinical literature. You can start in middle age. It reverses functional declines in at least some tissues and organs. It seems like you can take it intermittently and still get most of the benefits. That's all been shown in mice and other laboratory organisms. I think the fundamental question that we don't yet have a good answer to is, how effective is rapamycin at improving health span and or lifespan in people or in dogs? We talked a little bit about the dog rapamycin trial. And which individuals are likely to get benefits from rapamycin, and what are the risks associated with rapamycin? I think we've learned a bit from off-label use of rapamycin. So people who are being prescribed rapamycin by their physician, who are taking it regularly for the hope of improved health span, potentially increased lifespan. Some of the things we've learned is that in general, at the doses that people are using rapamycin off-label, it is extremely safe. The only side effect that is statistically significant is mouth sores. About 15% of people will get canker sores when they take rapamycin off-label. Other than that, there is nothing with glucose, nothing with lipids, nothing with cancer that looks yet to be statistically significant as a risk of using rapamycin off-label. Those are the things people are worried about. Immune suppression is where the risk of cancer would come from. We don't know, though, for sure what the long-term risks might be because there haven't been very many people who've been taking rapamycin off-label for more than 5 years. So it is still possible that we will uncover some long-term risks. It also seems to be the case that a subset of people have very profound improvements in quality of life. This is where I'm going to be clear. It is my speculation that those are people who have high levels of chronic inflammation, often chronic inflammation, that is the result of a prior viral infection. Not always, but often. Those people will start taking rapamycin sometimes and feel better because they've had all of this chronic inflammation that's been making them feel bad. This seems to be true in chronic fatigue syndrome. It seems to be true in some cases of long COVID. The other place where rapamycin looks to have really interesting potential benefits in people is in people who are at high risk of Alzheimer's disease or other dementias. So there are an accumulating number of studies now in people who, for example, are carriers of ApoE4, which is a risk factor, genetic risk factor for Alzheimer's disease, where we can see improvements in cerebral blood flow and brain volume after people have been on rapamycin for 6 to 8 weeks. It's early. It's not a large population clinical trial yet, but intriguing, and it fits very well with a large body of literature in rodent models of dementia and Alzheimer's disease. So intriguing, I would argue pretty compelling for people who are in that particular category and are concerned that they may go on to develop Alzheimer's disease. The other place that we don't yet have data are the clinical trials that are ongoing. They're all small, unfortunately, but there are clinical trials looking at periodontal disease, ovarian function, muscle function in different contexts. And so I think we'll start to get some ideas whether rapamycin has positive, negative, or net neutral effects for some of these other outcomes that we're interested in. And then, of course, we've got the clinical trial in dogs that we already talked about. Hopefully 4 years from now, we'll be able to publish the results and answer the question, does rapamycin increase lifespan and health span metrics in dogs? So it's been slow, unfortunately, but that's just the reality again of the way things work in a situation where there aren't sufficient incentives to do the real clinical trials to answer the question. Again, if we could go back 10 years ago when I was arguing way back then that we should be doing these large scale clinical trials with rapamycin for Alzheimer's disease, we'd know by now if the Alzheimer's disease community had actually gotten on the ball and done the clinical trials. They didn't. We still don't know. And hopefully we'll start to get some real clinical trials, large clinical trials, as data accumulates and people become more interested. And again, I'll just finish up. I alluded to the fact that the incentive structures are also misaligned for pharmaceutical medications that might have an impact on aging biology, different from supplements. The challenge here with rapamycin, of course, is it's an already FDA approved, it's off patent. There is no incentive structure for a pharmaceutical company to do the very large, phase 3 clinical trial like clinical trials for rapamycin for all of the various age-related endpoints where it could have benefits.
What's your intuition? Will it be positive, negative, or neutral effect on muscle size?
I think it's going to depend on context, to be honest with you. So my intuition, and to be fair, I have some inside knowledge for at least one of the clinical trials that will be published soon. My intuition is that, and it'll depend on the person, right? So if you're talking about people who are untrained, right, who are going to get the most benefit from, for example, a resistance training regimen, who are untrained to begin with, and you only look at the period that they're taking rapamycin, depending on the dose, you're probably going to see either no effect or a small attenuation of the increase in muscle mass and strength during the period that they're taking the rapamycin. My intuition, and I don't have any data to support this, is that if you then followed those people, so if you cycle the rapamycin, say for a 10-week, 12-week period, if you then follow those people, you take them off the rapamycin and you follow them for another 3 months, what you'll see is that at the end of a 6-month period, they're as good or better. My intuition is even a little better than the people who never got rapamycin. And there's a plausible biological explanation for that intuition, but it's speculative, that the ability of rapamycin to boost autophagy and attenuate inflammation during the post-treatment phase will actually be net beneficial for overall changes in body composition. But again, this is going to be very context dependent. If you take too much rapamycin, so if we go to like organ transplant doses, my intuition is you would have a more pronounced negative impact on the ability to gain muscle mass. And if you were talking about trained athletes who are already have gotten that initial burst of positive outcome, there I actually think even during the training period, you might see benefits if you can attenuate the inflammatory component, right, in joints and tendons and ligaments. But it's speculative. We just don't have any data at this point.
All righty. Rob01 is asking, I believe Matt has said before that he recommends taking rapamycin in a fasted state versus with high-fat meal. It would be nice to confirm on that point and his reasoning, and if he has any data to show which administration route might produce better results.
Sure. So I'm not sure where that's coming from. I don't believe that I have ever said or even necessarily thought that you should take rapamycin in a fasted state. I typically, when I'm cycling rapamycin, will take it before breakfast, right? So I'll take it with a meal. I don't have any data one way or the other. You might get a little better bioavailability if it's in the context of a meal, just because digestion is going to slow it down. And rapamycin is unstable at stomach pH. That's why the formulation matters. So the tablets with binder, Rapamune or generic sirolimus in the tablet form, will be engineered to get to the small intestine before the drug gets released. If it's a compounded form of rapamycin, all bets are off. There are enteric capsules that compounding pharmacies can use that will help, but still the actual bioavailability is going to be quite variable. So I think the formulation probably matters more than whether or not you take rapamycin with a meal or in a, in the morning before you eat.
You already touched on the next question from Pove, but he would like to know more about what supplements rapamycin might synergize with, perhaps redundant if you take rapamycin, or antagonize, is that the right word? Doesn't work well.
Yeah, it's a good question. I'm gonna dodge this a little bit. I mean, I'll give an answer, but it's gonna be with the caveat that it's all highly speculative, right? That first of all, again, most of these supplements, we don't actually know whether they're doing much of anything. So it's gonna be based on what people think their activity is, right? So in terms of, I don't know if synergistic is the right word, but where conceptually it makes sense to combine would be, in terms of a supplement, something like berberine, right? So berberine is basically a metformin mimic. As far as I can tell, does the same thing metformin does, which we still don't really know what that is biochemically. It's just you can buy it over the counter instead of it being a prescription medication, which makes no sense, but that's the reality. So why might you consider combining rapamycin with berberine? There's one mouse study that suggested, it's not a very well-controlled study, but it suggested that metformin plus rapamycin might be a little bit better than metformin or than rapamycin alone for lifespan. Metformin alone has no effect on lifespan in mice. Metformin plus rapamycin might be a little better than rapamycin. And there are some concerns that rapamycin in some people can impair glucose metabolism, glucose homeostasis, and metformin or berberine would be anticipated to offset that. So that would be one where you could make a reasonable argument for combining them. If it was me and I was taking berberine for a glucoregulatory purpose, I would take a different thing. I would use an SGLT2 inhibitor, not berberine. But if somebody really wants to use berberine, I could see the case for doing that. You might also think about combining rapamycin with a senolytic drug. Quercetin, for example, is a supplement people talk about as a senolytic. Again, whether these things are really senolytic or not completely clear at the doses people take them. And the rationale there would be that rapamycin is very good at blunting the inflammatory component of senescence. So it's what's called a senomorphic, but it doesn't really clear senescent cells. And so if you hit the senescent cells with two hammers, so to speak, you blunt the inflammatory component and you have a senolytic that might kill them, you might get better clearance of senescent cells. Rapamycin might also boost the ability of the immune system to clear senescent cells. And so you're going to maybe get a more effective approach by combining. There's not really any reason to worry about any detrimental effects of combining those two approaches. So in general, combining rapamycin with the senolytic might make sense as well. The only thing where I would think about you might want to stay away from is something that could also inhibit mTOR, right? And so there are a variety of supplements that, people have talked about as mTOR inhibitors. I don't really believe that any of them are direct mTOR inhibitors or potent mTOR inhibitors. So I'm not really concerned about that. Conceptually is a place where you would not want to combine another drug or another intervention like fasting, like long-term fasting, with rapamycin for that reason, right? The goal of taking rapamycin is to inhibit mTOR and specifically mTOR complex 1. If you do something else that inhibits mTOR complex 1, basically it would be like taking more rapamycin in that, a much higher dose. And the whole point of the off-label dosing, the way it's done, is to specifically titrate mTOR activity and the length of time that we are inhibiting mTOR complex 1. So if you're combining it with something else that does that, you might overshoot the mark.
Coming from the bodybuilding world, I never was a bodybuilder. That's the literature that I
Sure.
was reading in the 2010s, right? When I was really into these things. But inhibiting mTOR is something that you just don't do. Anabolism, yes. Catabolism, no. Run
Yeah.
away. Just wake up at the middle of the night and eat something.
Yeah. Yeah.
Can you talk about this a little bit?
Sure. Yeah, I mean, you're right in the sense that if your goal is to grow as big and fast as possible, what you want to do is jack up mTOR as high as you possibly can, right? mTOR is one of the primary decision makers for growth versus stress resistance. And when mTOR activity is high, that is a growth promoting signal that tells the cell, the body, grow, build. And so, yeah, in the bodybuilding world, again, at least simplistic approach is ramp up mTOR as high as you possibly can, keep those growth promoting signals on as much as you possibly can until the point comes where you want to cut. And then you try to shut down mTOR so you can lose weight real fast, right? And so that makes sense if the goal is to build as much muscle and mass as possible. The consequences of always having mTOR on, though, are you get growth in places you don't want it, like your heart. You get hypertrophy, which is bad, and you get cancer, right? So if you always have the growth promoting signals on, that creates a lot of problems. You also get chronic inflammation, which contributes to a whole bunch of age-related diseases. So the right answer, if your goal is to optimize the system, is to turn TOR on when you need growth and regeneration, and to turn TOR down, not necessarily off, but to turn it down when you want repair, you want to reduce inflammation, you want stress resistance. And so that's
How do
really
you
what
know
we're
what you
talking.
want?
How do you know what you want?
Mhm.
I think what you're asking is how do we know when to turn TOR down, when to turn it up, how much to turn it down? We don't is the answer. We're guessing. We're taking educated guesses. I think where the data can inform us is that with age, there seems to be hyperactivation of mTOR, dysregulation of mTOR. So it is inappropriately high with aging in most tissues, not all, but in most tissues. And in laboratory animals, when we give them rapamycin, transiently, continuously, middle age, whole life, they live longer and they're healthier. So that points to a hypothesis that turning down mTOR a little bit with aging is a good thing, but we don't know how to optimize it at all yet. And so that's where there's a lot of uncertainty, where people are guessing. Is it 6 milligrams? Is it 6 milligrams once a week? Is it 4 milligrams once a week? Is it 1 milligram a day? And we don't know the answers to those questions because we haven't had the clinical trials. And so a lot of it has been anecdotal guesswork. We've been informed by a couple of clinical trials looking at a very specific endpoint, which is vaccine response in the elderly, where it looked like once weekly dosing is better than daily dosing, both in terms of efficacy, so better vaccine response in the elderly, and in terms of side effects. But it's a limited data set that we as a community have over extrapolated, but we've over extrapolated because we don't have any choice, because we just don't have any other data.
All right. Well, let me come with a lighter topic here. I wanted to ask you, what's your take on this whole Brian Johnson phenomenon?
I mean, I think high level, the positives are that he has raised awareness around the idea that you can take control of your health, that there are markers that we can look at to monitor and make early predictive changes to improve health. And he's engaged a lot of people in that idea. In some ways, he's also helped this build this idea of gamification of health. So that's all good. On the negative side, first of all, he's not scientific, and I struggle with that. His approach is not scientific. He has chosen not to surround himself with credible experts. And so that leads him to say lots of things that are untrue, mistakes. And I think in many ways, if you get outside of the longevity bubble, the enthusiasts, most people I talk to have a negative feeling about him and by extension about the entire movement, the entire space. I don't know if that's going to eventually be harmful or not, but it is the case that most people view him as a crackpot when you get outside of the longevity bubble. That's been my experience, at least. And so I do have some concerns that this is it is staining the credible scientific parts of the field with connotation that it's all, just snake oil.
Yeah, I'm similarly mixed on him. I actually like his vision, and the crazy part about him, that the normies don't.
The normies.
Perhaps the non-scientific part doesn't bother me as much either. I think there is a
Well, that's
little bit
again,
of narcissism there, that might be okay.
yeah, the only reason the non-scientific part bothers me is because I think it gives people bad information, right? And some people act on that information, right? I also say one of the things that, and again, I don't follow Brian Johnson or other people like that at all, unless it comes across my radar. So there may be things I'm missing, and what comes across my radar is a limited snapshot of everything they're putting out there. One of the things that has been my perception recently is his message has turned very negative and very much manipulating people through fear. You have to be scared of the microplastics. You have to be scared of the air pollution. You have to be scared of the toxins. And I'm going to sell you this stuff that will tell you if you've got these things, and I'm going to sell you other stuff that will help you get rid of it. I find that approach repulsive. I think trying to manipulate people through fear, which happens all the time, is something that I very much dislike. And I've seen, it feels like that's become more pronounced in his messaging, at least the stuff that comes across my radar. Should we be aware of microplastics in our environment and toxins in our environment and take reasonable, pragmatic steps to reduce that? Yes, we should. We have no evidence yet that this is a significant health problem, or how significant it is, or who it's a significant problem for. People do not need to live their lives in fear. They should be taking pragmatic approaches to limit their exposure to these things and not spend all their time having anxiety about it. And that's where I feel like this manipulating people through fear and anxiety is not aligned with the goals of helping people achieve better health, in my view.
All right. That's enough said. What's one thing that you strongly believe to be the case, but very few people agree with you on?
uh, I can't think of any. Honestly, I can't think of anything. I mean, I think if you talk about the broader, like if we talk about the broader population, I don't know if people would disagree. I think, I've already said that I believe the most impactful way to improve health for the most people is by understanding and targeting the biological mechanisms of aging, right? I firmly believe that. I don't believe that's a mainstream view yet. I think most people are still of the view that we should try to cure cancer or cure heart disease or, cure individual diseases. But I don't know that people fundamentally disagree with that viewpoint. I think they just haven't heard it or understood the why that is the the most effective approach to improving health. So I would love to see that message get out. And if people do actually disagree with that, have conversations around why they disagree. Because I think there are opportunities to persuade people that this is really what we should be doing if our goal ultimately is to give as many people and animals as much healthy life as we can. Maybe the last thing to add on to this, and this is not in relation to your question of what is something I believe that people disagree with, but it is, I think, an important nuance around what I said, which is that targeting the mechanisms of aging are the most effective way to improve health and longevity. There are different strategies that can be taken within that sphere, right? So my research has always been about understanding the biology of aging and slowing that process, maybe reversing it if we can, aspects of it for sure. There are other approaches that can be taken. Replacing parts of the body as they wear out is a different approach towards the same problem. The problem is the decline in function that goes along with aging. The way you solve it is different. That's okay. I'm all for that. I'm not suggesting that we shouldn't pursue those other approaches. I think what we need to agree on is the goal. The goal is to preserve health for as long as we can. The best way to do that is to offset the negative changes in health that go along with aging. And there are different ways to target that. And so I feel like within the community of people, even within the people who buy into that vision, sometimes there's this, unnecessary argument or debate about how we should be going about it. We should be doing it all, right? So that we can get to the goal, because that's the goal that we're trying to achieve.
Matt, it was a privilege and a pleasure talking to you.
You too. Yeah, this has been a fun conversation. You took me in directions I don't usually go.